Hey guys, welcome back to the QST channel. Today we'll be solving the term 2 week 8 chemistry quiz. Let's go. Calculate the enthalpy change in kilojoules per mole of the reaction between ethene and chlorine, given the bond energy values in the table below. Okay, since it's in bonds, which I'll mark as B basically, is equal to reactants minus products. So as they give it to us. So C double bond C. Let's start with parentheses. 602 plus. How many CH's are there? 1, 2, 3, 4. 4 times 413. We get all of the values of the bonds from the table they give us. Plus, don't forget to count the CL's here. 240. All of this minus C single bond C, which is 346 minus 346 plus. How many CH's are there? 1, 2, 3, 4. 4 times 413 plus 2 CCl. So plus 2, 327. 2 times 327. We put this into the calculator. 602 plus 4 times 413 plus 240 minus parentheses 346 plus 4 times 413 plus 2 times 327, which is equal to negative 158. And don't forget that it's into 4 significant figures, so negative 158.0. Number 2. Calculate the change when 275 grams of phosphorus trichloride is reacted with excess oxygen. Okay, so first we need to get the periodic table to know like the molar mass of phosphorus and chloride. Okay, so now we know that PCl3, after getting the molar mass from the periodic table, is equal to 137.5. Just let me make sure first. 137.5. Okay. And they want 275 grams. So let's so look here in the equation, they said we have 1 mole, which is 137.5 grams, and now they wanted 275 grams, which is basically times 2 of this. Okay, so now how do we go from 137.5 to 275? We multiply by 2, as we said. So we multiply the heat contents by 2 as well. So negative 287, negative 287.5 times 2, which is equal to negative 575. Negative 575. Number 3. Calculate the energy in each case. Okay, first of all, we need to know the heat contents. Like if it's endothermic or exothermic. If it's exothermic, it's negative. While if it's endothermic, which is true in this case, since energy is absorbed, or in the reactant side, endo, okay, it's gonna be greater than 0. So here we have 3 moles of carbon. So how do we go from 3 moles to 1 mole? We divide by 3. So we do 462 divided by 3, which is 154 kilojoules. If 1 mole of Fe is produced, here we have 4 moles. So from 4 moles to 1 mole, we have to divide by 4. So 4 to 1, we divide by 4. So 462 divided by 4 is equal to 115.5. If 1 gram of CS reacts, the molar mass of C, of carbon is 12. And here we have 3 moles. So it would be 3C would be 36 grams. But here instead of 12 grams or 36 grams, they want 1 gram. So how do we go from 36 to 1? We do 462 divided by 36, which is 12.83. Or, yeah, 12.8. Number 4. To change the temperature of a particular calorimeter, the water it contains by 1 degree Celsius requires 0.837 kilojoules. The complete combustion of 1 grams of octane in this calorimeter causes the temperature to increase by 8.2 degrees Celsius. Find enthalpy change. First of all, we need to find the Q first, which is the heat, which is the energy needed to convert a certain amount of grams of a specific material into, to change it by a certain degree Celsius, which we use MC delta T. But in this case, they didn't give it per gram. They didn't mention. So it's gonna be capital C delta T. So 0.837 times 8.2, 0.837 times 8.2 is equal to 6.86, and that's Q. But here they want delta H. There is a relation between delta H and Q, which is delta H is equal to negative Q, which we just found, over N, which is the moles. So now to find the moles, they gave us the mass of octane, right? And the molar mass. The molar mass is 96, which is 12 times 8 plus 18. 96 plus 18 is 114. So to find the moles, we do 1 which is the mass, over the molar mass, 114. 1 divided by 114 is a wrong number, which I wouldn't say, to be honest. Okay, and then now we do negative q over this. So negative 6.86 divided by 1 over 114, which is basically negative 6.86 times 140, right? Okay, 6.86 times 114. Don't forget the negative sign, and that will give us negative 782.4. Number 5. Calorimetry is the measurement of reaction heat. Wait. Just come back to this question. Number 6. Calculate the heat when 7.5 grams of C2H6 burn in excess O2. Okay, first let's find the grams of C2H6 in this equation. So 12 times 2 plus 6 is 30. So we have 30 grams in this equation, but they want 7.5 grams. So 30 to negative 1560, but I'm just gonna keep it positive, so I'll just put negative. And 7.5 to negative x, no, to x, sorry. 7.5 to x. 1560 times 7.5 divided by answer divided by 30, which will give us 390. And make sure to put the negative sign. Negative 390. 7. Which of the following equations represents the reverse? The reverse of an equation is basically you switch the reactants and the products, like you switch their places, and the sign of the delta H changes. So it's gonna be 2CO2 and 3H2O will give C2H5OH plus 3O2. So it's this. And the delta H is positive, so it's correct. Number 8. Number 8. Which of the following are true concerning the heat change of a chemical reaction according to Hess's law? It depends on initial reactants, final products, and on their states, and it is dependent on the path followed. So now, for number 9, drag and drop in the blanks for an endothermic reaction. Look, since we know delta H is products minus reactants, right? Okay, so now we know that an endothermic is reaction, like the reactants plus energy will give us the product. So that means the energy of the reactants alone is gonna be less than the energy of the products. Since we're doing product minus reactant, and the product is greater, delta H will be positive, which is basically greater than 0. As I said, products will have more heat content than reactants, and the reaction absorbs energy. Number 10. Which of the following is the energy diagram for an endothermic reaction? Look, so an endothermic reaction is when energy is absorbed. As we said, Like it goes from the reactants having less energy to the products having a higher energy. So it's gonna be something like this. Number 11. Now here comes the hard question. Nitrogen dioxide can be produced by using the following series of equations. Use the above chemical equations is used the enthalpy change. Okay. Now, according to Hess's law, forget the law itself, it's basically like using puzzle pieces to solve a problem, right? Okay. So first of all, we can switch this equation and divide it by 2, right? Okay, so 1.5 O2 will give O3, right? And so we do negative 427 divided by 2 as well, since we divide the whole equation by 2, even the energy, which will give us negative 213.5. And that will allow us to cancel the O3 on both equations. So now we just add the negative 122 and the negative 213, just to be sure. Okay, when you see the same like molecule, compound, element, anything on two sides with the same moles, cancel them out. If you see them with different moles, just subtract. So here we have NO plus O3, which will give us NO2 plus O2. They want us to get this equation, right? Okay, so O3 to O3 cancel out. This becomes 0.502, while this cancels out. Forgot to say that this is negative 122, and this is positive 213 since we flipped the equation. And we have NO plus half O2 will give us NO2, if I'm not wrong. Yeah. Okay, so now all we have to do is add these two, and that will give us 91.5. Please guys, in the exam don't forget to put the positive, even if it's positive and you normally ignore the sign, put it or you'll get a mistake. No, positive 91.5. Okay, number 12. Which of the following factors increase the rate of a chemical reaction between a solid and an aqueous solution? Increasing the surface area will increase the number of collisions, which will increase the number of effective collisions, which will in turn increase the rate of reaction. Increasing the temperature will increase the pressure, which will increase the speed of the particles, which will increase the collisions, increase the effective collisions, which increases the rate of reaction. Rate of reaction is basically like, how can I say it? Forgot what I was gonna say. It's basically effective collisions, rate of reaction. How does that increase? Increasing the concentration of the aqueous reactants, again, that will increase the collisions, which will increase the effective collisions, which will increase the rate of reaction. And the addition of a catalyst is basically an enzyme for the biology students watching. It's basically an enzyme which speeds up chemical reactions. Number 13. Based on the collision theory, a decrease in the concentration of a reactant decreases the rate of a reaction because the number of collisions between the particle decreases. Number 14. Which of the following best defines chemical kinetics? It is the study of reaction rates. Number 15. The reaction rate of the reaction can be expressed as the quantity of either the CO2 produced per unit time or the CH4 consumed per unit time. But it's okay. This is wrong because they said CO2. Wait, no, my bad. What? These two are both correct. No. This is correct because CH4 isn't produced. It's consumed. Sorry, guys. Choose the correct answer to indicate which of the graphs are obtained. When a gas leak occurs, it's basically like there is barely any product. So it's A. Only half the zinc is used as compared with the original amount used in C. Where is C? The original. So that's D because not as many like reactants are used, so it's D. Right? Yeah. And then a slightly warmer acid is used. It's gonna make the reaction faster, but like it won't increase the products. So that will be B. And then a greater mass of zinc means that the concentration of the reactant increases. So that's gonna be graph A. Because if the concentration of the reactants increase, then the concentration of the product increases. Part 2. The final volume obtained in experiment C is experiment C, final volume. Let's zoom in. Here on the left, on the y-axis, we have the volume C, which is this one, ends at 30 approximately. So that's the final volume. Number 17. Calcium carbonate, HeACO3, and okay. The mass of which of the following graphs shows what happens to the mass in time? Guys, do not get confused with the graph of the last question. Okay, the mass decreases because look, CaCO3, calcium carbonate, is a part of the reactants. So as the longer the reaction continues, right, the less the mass will be because it's splitting into, like, the bonds are breaking. So the mass of calcium carbonate will decrease, resulting in the graph looking something like this. Which of the following affect the rate of a chemical reaction? Concentration of reactants, the temperature, and the catalysts. I already explained these three factors a few questions ago. Calcium carbonate, CaCO3, and hydrochloric acid, HCl, react as shown below. Which diagrams would be suitable for studying the rate of this reaction? Look, we need the balance to find the mass of the reactant, and to be honest, for this question, just memorize. Number 20. Which of the following best defines the rate of reaction? It is the increase in concentration of products per unit time, and it is the decrease in concentration of reactants per unit time. Number 21. If the products have less heat content, as we said, I explained the exothermic earlier, and we said that it like endothermic, sorry, absorbs energy, and the delta H is positive. So if it's exothermic, if the products have less heat content, it's gonna be energy is gonna be released, the reaction is gonna be negative, and the reaction is exothermic, and the graph will look like this. Sorry for the bad curve, but that's reactants, and here is products. Number 22. Which of the following decrease the rate of reaction between a magnesium ribbon and hydrochloric acid? Decreasing the amount of magnesium ribbon, which is basically decreasing the concentration of reactants, and decreasing the surface area of magnesium, which decreases collisions, which decreases effective collisions, which decreases the rate of reaction. Number 23. Which of the following perturbations could have been done in going from experiment A to B? Look, the only case if, like, let's say we have a bigger graph like this with more products C, would only be if there is an increase in the concentration, right? Okay. Using magnesium powder, which is basically increasing the surface area. Using less amount of magnesium ribbon is not correct, because that means that it would be less, like the graph would be less. Warming the acid solution is increasing temperature. Adding a catalyst as well works, it's basically an enzyme. And decreasing the surface area is basically the opposite of using magnesium powder. So yeah. Okay. Which of the following is the most suitable method to determine the rate of reaction above? The change in temperature of the solution with time? No, because the rate of reaction is basically either the amount of reactants consumed or the amount of products produced per unit time, of course. So the change in volume of carbon dioxide, which is a product, over time. The change in mass of water over time, no, because it's a product. The change in concentration of hydrochloric acid over time, because we only care about the change in volume. The concentration is, yeah. We just memorize this question, okay? Number 24. Wait, there. Number 25. In general, if the concentration of KiO3 is decreased, the rate of the reaction will decrease. Looks like, from what we can see here, looks like, oh wait, sorry. In the question they said KiO3 solution and HSO3 minus solution are mixed together. That means KiO3 is a reactant. So if the concentration of the reactant decreases, the rate of the reaction will decrease. 26. If the temperature of the solution is decreased, the rate of the reaction will decrease. If the temperature is decreased, kinetic energy will decrease, meaning the collisions will decrease, effective collisions will decrease, rate of reaction will decrease. Consider the following tubes that contain calcium nitrate and 2 more HCl, we don't care. Select the tube with the fastest rate of reaction. It will be the one with the highest temperature, and I already explained why in multiple questions before. Thank you guys so much for watching this video. We wish you the best of luck in your exams, and goodbye.